Greetings everyone. I am Jyoti Bhumika, a student of Acropolis Institute of Technology and Research, completing Bachelor's of Technology in Computer Science and Information Technology. In today's video, we will discuss about introduction to key attributes, use of keys, different types of keys with their example. Let's start. A key refers to an attribute or a set of attributes that help us to identify a row uniquely in a table. A key is also used when we want to establish relationship between the columns and tables of a relational database. Use of keys. Importance. Keys are one of the most important aspect of DBMS, which helps us to identify tuple uniquely in a table. Design. It can be very beneficial to design a table and acquire the essential values respectively to its given attribute. Application. The creation of a strong and effective relational database requires the thoughtful application of these keys. Types of keys. There are several types of key attribute: super key, candidate key, primary key, foreign key, alternate key, and composite key. So now we will start with super key. Super key is an attribute set that can uniquely identify a tuple. Super key value may be null. The syntax of creating super key is create table student SID name super key contact. Here the student is the table name where the SID, name and contact are the attributes, and here the name is the super key. For example, consider the table employee. Here in this table, employee ID and contact is a super key because with the help of employee ID and contact, we can identify a tuple uniquely. Now, next is candidate key. The minimal set of attributes that can uniquely identify a tuple is known as candidate key. It is a super key with no repeated data. Every table must be have at least a single candidate key. It can be null for a tuple. Basic syntax for creating candidate key is create table student SID, name, number and contact. Here in this number is candidate key. For example, we have an employee table with attributes employee ID, employee name, employee age, and contact. Here, we can identify a tuple uniquely with the help of employee ID, so the candidate key is employee ID. Now, the next key is primary key. It is a unique key which can define only one tuple at a time. It has no duplicate values which cannot be null. The basic syntax is create table student SID, primary key, name and contact. Here the student is a table which has the attribute SID, primary key. Here the SID cannot accept the repeated values again and again. For example, here we have a table named employee which have attributes employee ID, employee name, employee age and contact. Here the employee ID is a primary key which cannot be null for any tuple. Foreign key. It combines two or more relations at a time and act as a cross-reference between the table. The basic syntax of create foreign key is create table student SID, name, course and contact, where the course is foreign key. For example, we have a table employee with employee ID, employee name, employee age and contact, where contact is a foreign key. Here it means that the contact is a foreign key which is the primary key of the another table. Now the next key is alternate key. All keys which are not primary key are called alternate keys. It contains two or more fields to identify two or more records. The values are repeated. For example, Consider the table employee ID as well as contact. Both are the candidate keys for the relation employee, but the contact will be as alternate key, only one out of many candidate keys. Composite key. It acts as a primary key if there is no primary key in a table. Two or more attributes are used together to make a composite key. The basic syntax of creating composite key is create table student, SID, full name, date of birth, and contact. Here, the full name and date of birth can be combined together to access the details. For example, consider the table employee. The employee name and employee age can be both combined together to identify a tuple uniquely in a table. So, thank you everyone.